Okay, so again, 12.5 is permutations and combinations. Again, today we're going to do the permutation part of this, okay? So if we start with the fundamental counting principle, and we've actually already done this, we just didn't know its name, which says when there are m ways to do one thing and n ways to do another, then there are m times n ways of doing both. So if you think back to like, we had examples where you were trying to figure out how many shirts or pants or something like that you could put together. And we took and multiplied however many shirts there were and then however many pants there were. And that would be the total number of different ways that you could arrange those. We did this with like rolling a die and flipping a coin. And we would say that there are 2 outcomes on the coin and 6 outcomes on the die. So you would multiply those out to find out the number of ways something can be done. That's the concept here. So for the first example that's there, it says you have 3 shirts and 4 pants. So if I wanted to piece together outfits, that means I would do 3 times 4 or 12 different possible outfits. If you have 6 flavors of ice cream and 3 different cones and you wanted to figure out all the different combinations that you can make for your ice cream cone, it would be 6 times 3 or 18. Okay, so you just multiply out the number of each. This is a factorial. So a factorial, if you've never seen one before, is a number with an exclamation mark at the end. It doesn't mean you're excitedly yelling that number. Okay, it means that it's a factorial. And a factorial just means you multiply that number times the number 1 less than it, times the number 1 less than it, times the number 1 less than it, until you run out of numbers. So for example, if you saw 4 factorial, 4 with an exclamation mark, this is the same as saying 4 times 3 times 2 times 1. Yes. If it was 10, it'd be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? There is a button on your calculator that does it.
At 0?
You don't, no. If you look at your calculator, the one that you're specifically allowed to have, you have a little button that says PRB. Okay? It's like diagonal from your yellow second button. And if you click that button and then you arrow over, the third thing over is your exclamation point. So if I did 4 and then I did, go PRB and arrow over and hit enter underneath the exclamation mark. You should get 24.
Where's the answer button?
The equals button. Okay, and 0 factorial is just 1. So it is not 0. 0 is a weird case. Okay, 0 factorial is just 1.
We have to put the number first, no?
You have to put the number first, yeah. So if I did 4 factorial, you would do 4. You would do PRB, arrow over, hit enter underneath the exclamation mark.
What if it's like a equation?
What do you mean? You would simplify it a little bit at a time.
Wait, is 0 always 1?
0 factorial is always 1. Yep. All right, so we're going to use this a couple different ways. If it was just obviously 4 factorial, you could do that in your calculator, but we're going to use this in a combination of multiplying out with other things, so you also need to understand how to break it down. So you need to understand both parts. All right, so a permutation is an arrangement of objects in which order is important, and that's the most important part. Order matters here. This is where the wording gets specific and you have to pay attention to it. So if it says order matters, then it means it's a permutation. We're going to get to something called combination in which it doesn't. The number of permutations of n objects is given by n factorial. So if I have 10 kids standing at the front of the room and I have 10 empty chairs, and I want to figure out how many different ways I could fill those chairs with those 10 kids, right? So let's say they're all standing at the front. Let's say Santi is first and eager to be placed in a seat. And there are 10 empty chairs in front of him, okay? How many different places can I put Santi? 10. Now I sit Santi down. And next in the line is Dylan. And how many seats are now available for Dylan? 9. And I keep going like that until everybody's placed. So as you keep going, you're going to reduce at 1, which is a factorial. okay? If I had 10 objects and I wanted to place them on the shelf and I wanted to figure out how many different ways I could arrange those 10 objects, it's the same. It's 10 factorial, okay? That's if you're using all your objects or all of your people if you're placing, okay? Under that says the number of permutations of n objects taken r at a time is, and this little NPR is what we call this, okay? But this formula is n factorial over n minus r factorial, where n is the total number and r is the number you're pulling from that. So let's say all 35 of you are in the room and I only want to sit 5 kids from that 35. So if from that group of 35, I want to figure out how many different ways I could pull 5 people at a time and put them in an order, then that would be P 35 would be the number of total people. R, if I want to sit 5 people or put people in 5 seats, then that's how it looks. In the equation or in the formula, I would do 35 factorial over 35 minus 5 factorial.
What's the difference between the two?
The top one is if you're using all of the objects or people, and the bottom one is if you're only pulling a certain amount at a time. Yeah.
What are the opposite sides of equals?
What?
Like, that one.
This is that, and this is that. Yeah.
Is there parentheses around the bottom part?
It doesn't matter. There is, but in this case, it doesn't matter.
Is it 35 times 34?
No, it's 35 minus 5. So I would do 35 factorial in the top, and I would do 30 factorial in the bottom. So let's say you didn't have a calculator. This would be 35 times 34 times 33 times 32 times 31 times 30 factorial. And that would go over the 30 factorial, and you could actually simplify it that way instead of multiplying it completely out. If your calculator has that factorial button, then it's not a big deal to write this in it. But if it doesn't, let's say you're using like a 4 function or something, it won't have that factorial button, then you would want to expand it out like the bottom. I would take the bigger number, break it down until it hits the smaller number, and then I would just be multiplying these things out. So 35 times 34 times 33 times 32 times 31. Hello. Okay. Yeah. Yeah, as long as they're both like 30 factorial over 30 factorial.
You would just put 35 with 30?
No.
You can't cancel out the exclamation point.
You can if they're the same. So I'd had to break the 35 down until I hit 30 factorial. Those could be canceled out, just like it says right here. Those could be canceled out, but all of this is still left. So if you in your calculator did 35 factorial divided by 30 factorial, you'd get the same answer.
Okay.
38 million, no, yeah, 955,840.
38 billion.
38 million.
That's what?
That's how many different ways you could arrange 5 people from a group of 35. So like if 35 kids stood at the front and I pulled 5 seats and I said, how many different ways can I fill these seats if I only take 5 people at a time? I could take any 5 at a time. So it's more than just 5 people by themselves. It's 5 from your group of 35. Yeah.
Can you simplify?
I-
35 over 30.
No. No. It's like all right. Example 1 says, in how many ways can you arrange the letters in the word mouse? So good. First, you got to look for 2 things. One is, what is order important here? Yes, we're rearranging the order of the letters, right? Because that's going to come into play when we start to get into combinations. So order is important, which means it's a permutation. 2, are we using all of the letters in the word? Yes. So now it's just the factorial. So it'd be 5 factorial, or 5 times 4 times 3 times 2 times 1, which is 120. B says, in how many ways can you arrange 3 letters of the word orange? So it's a permutation because it's how many ways can you arrange them, but are you using all the letters? No, you're using 3 at a time. So we're going to do P, the total number of letters, 1, 2, 3, 4, 5, 6, taken 3 at a time. So I can do 6 factorial over 6 minus 3 factorial. I can make that 6 factorial over 3 factorial, which is 6 times 5 times 4 times 3 factorial over 3 factorial.
Wait, how would you put the 6p3 in a calculator?
I didn't do it yet. I'm going to simplify it without the calculator first, and then I would do it. So 6 times 5 is 30 times 4 is 120.
What does the p mean, though?
Permutation. So it means how many times can you reorder them. All right, in your calculator, you underneath that probability button have the same, it says NPR. The order of which you do this is important. You have to type the 6 first. Then you have to hit the PRB button.
NPR.
Then you have to select the NPR. And then you have to put the 3.
Nice. That's it?
Yep,
120.
correct.
That makes it so much easier.
Questions? Yep.
Do you have to simplify before you put it in the calculator?
No, that would be if you didn't have the calculator that has the NPR.
So permutations when it tells you only like a specific number?
No, permutation is how many different ways can something be arranged. So the order matters. If it's all the letters, that's when it's n factorial. If it's some of them, that's when it's PNR.
Yes, yeah, so like so it says like everything range 3.
Correct. Yep. All right, example 2. Your band has written 12 songs and plans to record 9 of them for a CD. In how many ways can you arrange the songs in the CD?
12, D9.
Good.
Oh my gosh.
The n is 12. We're not using all of them. We're using 9, but we can arrange them in different ways. So it's permutation. So 12, NPR, 9. 79,833,600. There's no billion in there.
Wait, what goes after 1,000? No, what goes after?
Okay, now example 3 says, for a town parade, you will ride on a float with your soccer team. There are 14 floats in the parade, and their order is chosen at random. Find the probability that your float is first and the school chorus is second. So now we're getting into probability. Okay, so if I wanted to figure out just the number of ways it can be arranged, ignore the probability part of this. How many ways can the floats be arranged? How would I do that?
Would it be 14 exclamation?
Good. So then the number of outcomes is 14 factorial. If it had just said, find the probability that your float is first, you would just be worried about that very first spot, okay? But it's saying, what's the probability that you're first and the chorus is second? And then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm going to show you a shorter way to do this, but think about the process first. All right, so we're going to assume you are first. We are going to assume chorus is second. How many are left to fill that third spot? 12. Then we assume one gets chosen. How many are left to fill the next spot? 11. Then. What does this look like? It's a factorial, okay? So notice we took out 2. We are assuming the 2 we want are there. So those are already spoken for. That's why we don't do all 14. So we take out the 2 we want, and our favorable outcome, or what we want to get, would be 12 factorial. So we put 12 factorial over the total amount of outcomes, which is 14 factorial. So take away, in the numerator, it is the total minus however many you want. So if I wanted specifically somebody to come first, somebody to come second, somebody to come third, now it would be 11 factorial over 14 factorial.
What if it was like in the middle spot? Like,
You would still assume that that spot gets taken.
But that would be, so if it was like 9 and 8. What do you do?
It doesn't matter where it goes. There would still be the same amount. They would just be at the start, but
Okay.
it would be the same, and then blocked, and then
Yeah.
it would be the same.
Okay.
Yeah. All right, so then this 12 factorial over 14 factorial could be 14, 13, 12 factorial. That could be simplified, and it'd be 1 over 14 times 13, 182. You could have also done 12. This is when it's easier to simplify, though. I could do 12 factorial, which is 4, 9, hang on, over 14 factorial, which actually gives you 8.7 times 10 to the 10th, which means you'd have to move this back 10 places, right? And then it's harder to simplify. So this is a case in which it'd be easier to break it down like that. Take the bigger factorial, break it down until you hit the smaller factorial, and then cancel out from there.
So in the calculator, I could just put 12 factorial over 14 factorial.
Yeah, but then you're going to get a decimal, and you don't want a decimal. You want it to be an exact fraction. So you're not going to do that way.
And you know what to round it to?
You're not going to round it. You're going to keep it exact. That's why you don't want to do it that way.
So the answer is 1 over 182.
Correct.
And what is, have we talked about what happens when it says the school course is second?
This is, so the year first, and the school course is second. It's a weird example. We're going to do another one.
Are we doing the example easier?
It's weird, but once you figure out how to do it, it should make sense. All right, number 1. Find the number of ways you can arrange all the letters in the word boundary, and then 3 of the letters. So this is a 2-parter. All the letters would be what?
9x tells me
1, 2, 3, 4, 5, 6, 7, 8. I was going to say, I think so. 8 factorial.
Oh, I thought you wrote 9. My bad.
Oh, that's an A. Sorry. So this is 40,320. So that's how you could arrange all 8. B, what about 3 at a time? This would be P8, 3. $336. What's 6P3?
Well, that would be obviously, you do it factorial.
Yeah,
120.
good. And then 14, 9.
7 mark. 7 is 405,700.
Good.
Nice. 726.
Question so far? Yeah. The first, it's 2 parts. The first one says, how can you arrange all the letters? So when it's all the letters, it's the factorial of it.
It's just the letters.
And then it says, and then 3 of them, now you're pulling out 3 of them, so that's the PNR.
Wait. Oh.
It's like 2 separate
Yeah.
things.
But if you were like just do it on paper.
So if you were to do it on the paper, it would be 8 factorial over 8 minus 3 factorial.
So we did 5 factorial.
Yep, 8 over 5, and then that would be 8, 7, 6, 5 factorial.
Would it be better if we did it with those ones rather than the calculator ones?
What do you mean? I would just say know how to do both, because that is a skill you could do without a calculator. So let's say an SAT or ACT does not let you use a calculator, or you only have the opportunity to use like a 4-function one. You can do those without it by setting that up. Something that's like obviously as big as 14.9, you could still do it, but you could also use that button on your calculator. Good? Okay, 4, there are 8 students auditioning for the main role in a school play. The order of the student auditions is chosen at random. Find the probability, so we're back to probability, which means it's going to be our fraction. The probability that you're chosen first to audition and your friend Petra is chosen second. Yep.
6 factorial over 8 factorial.
Okay, so 8 factorial is the total amount, right? That goes in the bottom. So that's your total number of outcomes. And then you're setting you and Petra, which means 2 less than the 8, or 6 factorial. So I could do 6 factorial over 8 times 7 times 6 factorial. And this is 1 over 56.
So what if it says that your second's the addition?
Is Petra also still placed somewhere?
I should just place first.
Then it's the same. Even if you're second and she's third, it's still the same.
Okay. So all it is that it takes up 2 spots.
Correct. So 2 spots are spoken for. If it was 3, it was 3 people, it'd be 3 spots taken.
This isn't that hard.
It's not. Agreed.
Wait, so this is the furthest it goes in hardness?
And what?
In hardness?
No, what gets more complicated is that on tomorrow's section or tomorrow's part of this section is you start to do something with a combination in which order is not important, and the hardest part is figuring out which one they mean. Is it that order is important, or is it that it's not?
So it's about reading skills.
Is this some
Yeah.
hardest lesson on the test?
No, I don't think it's different for everybody.
Why is it
Some people think this is not bad.